Jeff Ely, who's at Northwestern, but I believe was an undergraduate here, is that right?
Yeah.
Many years ago, yeah. So this is an Irvine product, this paper. So this is sort of work in progress, and it's my first presentation of it as well, so it might be a bit sloppy. All right, so here's a scenario we have in mind. Okay, there's an attack planned on Christmas Day. Okay, you know there's an attack planned on Christmas Day. You're a few weeks before that, and you've caught somebody during some counterterrorism operation. You got him in custody, and he may or may not know something about the impending attack. There are two possibilities. One is he was a passerby, okay, during the counterterrorism attack, going to have lunch with his friends or something, and then, he got caught up in the operation. He's completely innocent. Or maybe he is a bit of a terrorist, but kind of low level. Doesn't know too much about what the higher ups. He's just a driver for Osama bin Laden or something, right? So he's a low level guy, not a high level guy. In that case, we'll say he's innocent or uninformed. The other possibility is that he's a high-value target. He was involved in planning the whole thing and knows a huge amount of stuff. And if you get it out of him, it would be very, very useful in stopping the attack or reducing its force. Okay, there are these two scenarios. And this kind of situation, it turns out, is kind of a generic scenario. Okay, and there's a sort of book by a former kind of American interrogator in Iraq called How to Break a Terrorist. Okay, his name's Matthew Alexander. And this is the kind of scenario that he describes repeatedly. You've got somebody in custody. Is this guy a low-level guy or a high-level guy? You want to know, okay? And of course the big problem is the high-level guy is pretending to be the low-level guy, right?
There's one thing that's not standard there, and that's the assumption that a terrorist attack is planned for a major holiday. We generally don't know that.
Yeah, so right now we've got, this is the scenario we have in mind, yeah? Okay? We're looking at other models as we go along, but this is the model we've solved. Exactly, you got it. Exactly. So that's the next bullet point, right? So you're in this scenario. For the sake of argument, in this paper, we assume that torture is the only instrument you have available to extract information from this suspect. Okay? And you face this trade-off. The information may be very, very valuable, but the means you're using to get this information is very it's kind of morally abhorrent to society. Okay, so that's the trade-off.
What if there is evidence against this assumption?
Sorry?
What if there is evidence against this assumption, which sort of that this is the only way, the only instrument?
You could look at some other things. I mean, this is the case. You could look at many scenarios where you can use money and I don't know exactly what you have in mind. Yeah. But you could use other instruments as well as torture, or again, different from torture. You could look at many extensions of this. Okay? But our benchmark model is torture alone. Okay? All right. So you could do kind of a utilitarian calculation and compare kind of the expected value of information to the expected cost of torture, and just go through with it.
In the cost of torture, are you also including the fact that the person might be set free because breaking rules, governmental rules?
The cost of torture, we're going to basically look at a normative benchmark, okay, in this model. Well, the costs of torture, I'm going to imagine, are the costs to society of conducting torture. Okay, then you can vary that and model the costs in different ways if you so choose. But what I'm going to establish here is, if you want, a normative benchmark.
And if the suspect is really uninformed and you torture him,
Yeah.
this model assumes that he just says,
You'll see.
nothing.
Yeah,
Okay.
you'll see. Okay. So that's going to be the big issue, you know.
Not the way we treat students.
Right. So you're going to look at this utilitarian optimum, and then it might be, if you do the utility calculation, that it's the optimal thing is to torture. Okay, and this point's been raised. Okay, so for example, Posner says, you know, if you know there's a nuclear bomb going to go off in Times Square, maybe torture should be used to obtain information. Okay. So as I just said, I'm going to try and establish the optimal policy for society with respect to torture along the lines Posner is suggesting. But the main thing I'm going to look at, okay, the main sort of issue in the paper that we have to try and handle is we're looking at the case where the torturer / society, the principal more broadly, cannot commit to a torture incentive scheme. For example, suppose the guy starts talking. So you learn he has valuable information, okay? At that point, let's just apply the Posner argument again, okay? If he has some information, he hasn't revealed all his information, well, this utilitarian argument says, hey, we should carry on to extract more information, and more, and more, and more, and more, okay? So that's the commitment problem, or a commitment problem that's going to arise in our model, okay? So let's look at this normative benchmark for society, assuming society cannot commit to a torture scheme. It's hard to commit to an incentive scheme even in a contracting situation. Okay? It's going to be even harder in this sort of situation, which is on the fringe of legality. Once we've got the thing, the optimal scheme, we're going to do sort of comparative statics with it. Suppose waterboarding becomes available. You know, how does that change the principle's optimum? What if you can torture for a long time, longer and longer time, or more frequently? How does that change the optimum? Okay, so those are the questions we're going to ask. Here are the kind of answers we get. One issue without commitment, we can show that in any equilibrium of this game that we're going to study, if you find out the suspect you have in custody is informed, you're then going to proceed to extract all the information you have from him in the time available. Okay? So once he starts talking, he talks all the way to the end.
And it's all verifiable information immediately.
Yes. Okay? Second, there's a second, so that's one issue that's going to come out. The second issue that's going to come out is, suppose you find out somehow that the guy's uninformed. Okay? He's making stuff up, or saying silent, or whatever he's doing. He's making, but the stuff he makes up doesn't check out. Okay? And if that's the strategy of somebody who's uninformed, you find out they're uninformed. And if you find out they're uninformed, then again, in the normative benchmark, since you don't actually like torture, you'd stop torturing. All right? So there are two commitment issues that come out. The first commitment issue is once the guy starts talking, you can't commit to stop torturing him or threatening him with torture to extract more information. The second commitment issue is if you find out the guy is uninformed, then you can't commit to carry on torturing him. Okay? So to deal with these issues, what turns out to be optimal is for the informed suspect to lie with positive probability in every period to give the principal the incentive to continue. You can interpret it like that. And you can calculate, there's going to be this randomization probability occurring every period. So those are the two issues that the principal faces, and the optimal scheme maximizes the principal's utility subject to these two kind of properties. Okay, and we find that scheme, and I'm going to go into that scheme. Comparative statics. So once we got that scheme, here are the kind of results we find. Enhanced interrogation techniques can reduce the principal's welfare. Having a long time available to torture can mean that in the end, the value of torture is negative, in fact. and you might as well just not torture to start off with. Okay? And in fact, being able to commit to a limited time to torture would be good. The more frequently you can torture, the worse it is. So if you have a lot of time, you can sort of split a day up into many, many little sessions. That's worse. And in fact, as it becomes really, really frequent, again, the value of torture becomes negative, and there's no point doing it. You're never going to get any information out of it, or it's so costly to get it out of it, get information out that, it's better just to stop. So those are the results, okay? So how much time do I have about?
You have until about 35 minutes.
Okay. The related literature is in kind of contract theory with little to no commitment. All right. So one issue that occurs in our paper is when the principal discovers the agent's uninformed or innocent, he has an incentive to stop torturing. Okay. There's no information there. Torture is costly to society. Stop. Which makes the victim better off because you stopped, and it makes you better off by definition because the benefit-cost ratio is such that you should stop. So it's mutually beneficial, stopping torture sometimes. And that issue comes up in contract theory or mechanism design with renegotiation, where you can rip up a contract and replace it with one which makes all parties better off. And it comes up in literature on the Coase conjecture, where when you find out a guy is lower value, a low value buyer, you cut the price. It's good for him, gets a better price, good for you, because you get to sell the thing, okay? So one set of incentives that come out in our model are going to be related to this renegotiation literature. The second commitment issue that comes up is once you discover the guy's informed, you want to carry on and extract more and more information out of it. And this is related to work in regulation on the ratchet effect, where if you find out a regulated firm is low cost, then the next period you're going to give a tougher incentive scheme with a lower price or higher output. Okay? So those two incentives are going to come out in our paper, and it's all about balancing these two off optimally. All right, so here's the model. Terrorist attack known to be planned time t after you get the suspect. Okay? That might be, you might know that the thing's happening at time t, or maybe the government forces you to give up the victim, or that some law forces you to give up the suspect in t periods after you've got him in custody. Or maybe the value information decays endogenously. So there are many ways to generate this T, but right now we just got an exogenous capital T. Time's continuous, but it's chopped up into intervals of length L. So if you've got capital T time and length L, you've got little t periods to do your thing. In each period, you can impose a cost capital delta. There are two costs, two key parameters in this paper. A cost delta you can threaten the victim with, and a cost C that you incur from carrying out torture. So these are two key variables. Third, the guy might be uninformed or informed. And he's informed with probability mu0, and uninformed with probability 1 minus mu0. Okay? And Sturgis just mentioned this. So if the guy's informed, his information is verifiable. He gives you something, he tells you where a safe house is, and you go and check it. Okay, either it's a safe house or it's not a safe house. Or he pretends something is a safe house, and it's not a safe house. Okay? So the uninformed guy, all he can do is pretend, make up information, or stay silent. Okay? But the informed guy can give you valuable stuff. And for simplicity, it's divisible. All right? So we're going to look at an upper bound on the principal's welfare and show it's very low. If you made it unverifiable, it'd be even lower. Okay? So we're looking at the best case scenario, so to speak, for torture, and we're going to show even the best case scenario is pretty bad. If the suspect reveals Y information, the informed suspect, and is tortured for T periods, then his utility is X minus Y minus capital delta T. And if the principal tortures for T periods and get Y information, his utility is Y minus CT. And if you're uninformed, all you're doing is getting the cost. So you're going to get minus delta T. So those are the utilities. And I guess I'll do the full commitment story. Very simple full commitment story, which will be the kind of like the benchmark, if you want.
Presumably,
Yep.
the high-level guys have a higher cost. So instead of having minus y, it should be minus theta upper by y or something like that, because the cost for betraying the organization is high-level guys. But that's an extension. So.
Yeah. So the uninformed guy can't betray anything anyway. So in effect, this guy does have a higher cost.
Oh, that's right.
Yeah. The uninformed guy has no. Yeah.
Got it.
Yeah. Okay. So in effect, he has a higher cost.
Yes.
Yeah. So first of all, in the full commitment benchmark, here's the story. If you want to get information Y from the informed guy, you've got to threaten him for TY periods where delta times TY equals Y, right? So you can either reveal Y or he can be inflicted with torture, which is just about the same. And so he's indifferent between lying and telling the truth, so let's just have him tell the truth. Okay? So this is what you have to threaten with him with to get the truth out of him. TY. The uninformed guy, he can't reveal anything. He doesn't know anything. So he's just going to get tortured for TY periods. So we can calculate the expected utility to the principal. With probably mu0, you've got the informed guy, and you get Y out of him. With probably 1 minus mu0, you've got the uninformed guy. This goes to your question, actually. You've got 1 minus, you've got the uninformed guy. You torture him for TY periods. That costs you C. So this is your expected utility at the benchmark. We can substitute in for TY. It's Y divided by delta, substitute it in here. Factorize out the Y. And you got something in the big brackets here. And so the full commitment optimum, you just look at the thing in the brackets. It's all the parameters. The three key parameters of this story are mu0, C, and delta. They're all in there. And if this thing is positive, you go to one corner. You extract all the information possible in the time you have. And if it's negative, it's not worth it. Okay? Notice you're torturing the innocent here, which is abhorrent to you. Posner hasn't quite worked that part out, but if you want to do this stuff, you're going to end up torturing the innocent. If the probability of the guy being innocent is high, you're not getting much information, you're just torturing the innocent, okay? So that's the utility trade-off, and it just gives you the solution, okay, the full commitment solution. So that's a very easy benchmark. Now let's look at the case with limited commitment. That's the case that's of interest.
Sorry, but even in the full commitment case, you could do some updating of period by period, no? On whether
It doesn't matter.
doesn't matter.
It doesn't matter. I mean, basically, this is like a screening model. Whether there's time involved or not time involved doesn't matter. Okay. There's no time actually in this characterization. Okay. You either say you either reveal your information or you're threatened with or you submit to torture for TY periods. Okay. If you did it temporarily, the informed guy will reveal his type immediately, give you up X, the information he has, and the uninformed guy would just submit to torture. At that point, you know he's uninformed, by the way, but since you've got full commitment, you've committed to torture him per se for TY periods, you just have to carry on. Okay? But of course, temporarily, with no commitment, you're going to have trouble. So limited commitment, the principal can commit one period at a time. He can say, give me some information. He can demand a quantity of information and say, I'm going to suspend torture for this period if I get the information. But what he can't do is commit to a cessation policy. He can't say, at the end of the period, I'm going to stop. Or at the end of the period, I'm going to continue. Okay? At the end of each period, he decides. Updating, as Massimo said, updating whether to continue or not. All right? Given what happened in the previous periods. Keep things simple, and I've been doing this already. We're just going to have like we're going to ignore non-integer periods and things like that. Okay? And a key variable, a key thing that's going to be important is this k upper bar. K upper bar is defined, so k upper bar delta is exactly equal to x. So if you have k upper bar periods and you can get delta per period out of the suspect, you get all this information. Okay? If the number of periods is less than k upper bar, number of periods you have available is less than k upper bar, you can't get all the information out of him. You don't have enough time. And if you have more than k upper bar periods to torture, then you've got the luxury of time, so to speak. All right? So we're going to, if we're going to measure time backwards, it helps to reduce notation, but maybe it's a bit confusing. So period k for me will be k periods to go. So period 1 is the last period, and period little t is the first period, so to speak. Okay? And if k is less than k upper bar, I'm going to say we're in the ticking time bomb scenario. All right? And the solution for the game depends a bit on whether k is in there or out of there, so that's a useful phrase to have in your back pocket. All right, this is the first time I presented this thing. I didn't quite know how to do it, so here's my strategy. So I'm going to give you some definitions, which are going to seem a bit abstract, and you're going to think, what the hell are these about? And then I'm going to describe the equilibrium and use the definitions. But there's a chicken and egg problem. I can't define the equilibrium until I define these things, etc. So I'm just going to have a few slides with some definitions. And I'm going to try and give intuition for them. And in this, what I'm going to try and do, as the slide said at the top, I'm going to try and find the best equilibrium for the principal. There could be multiple equilibria in this game. I'm going to look at the best one and show its value and do comparative statics with it. Okay? So V1, mu.
Sorry, the strategy here of the principle is how many periods to torture?
No.
No?
The strategy of the principle is each period he can demand a quantity of information,
Okay, so yeah.
and at the end of the period he decides whether to continue or cease.
Yes.
And he decides that as a history of what's happened up to now. Okay? So first of all, I'm going to define this quantity V1 mu. And it's going to be related to the last period of the game, which is period 1 in my notation, okay? Suppose you come into this period with the belief mu that the guy is informed. And you do like a 1-period threat. And let's say the informed guy then talks, and then the uninformed guy doesn't talk. The most you can get out of him in one period is going to be kind of delta. That's the 1-period threat you can use. Okay? Of course, he may have even less information than that. If x is less than delta, you're going to get x rather than delta out of him. So there's a min x delta term here because of that possibility. But up to delta, that's the maximum you can get out of him is delta. Okay? So you might get this thing out of him with probability mu. But if the guy is uninformed, which he is with probability 1 minus mu, you're going to get C. Okay? So this defines the expected utility for the principal in a 1-period torture scheme, given beliefs mu, if the informed guy reveals with probability 1. The first variable I'm going to define is mu star 1. Mu star 1 is the belief for the principal that makes him indifferent between torturing and not torturing. For V1 mu star 1 equals 0. Okay? So you're just going to find the mu that sets this equal to 0. All right? In our equilibrium, what's going to be very important is keeping the principal indifferent between torturing and not torturing. All right? That's part of our equilibrium construction, so that's why this mu comes up. Now I'm going to fold, that was period 1. So now I'm going to fold back to period 2, give you some intuition for what happens in period 2, then hand wave and get you to period K. Suppose you're in period 2, and the suspect reveals information with probability Q. If he's informed. If he's uninformed, he can't give you anything solid anyway. So suppose the informed guy gives you up information with probability Q. You come in into period 2 with beliefs mu. Okay? So coming out of the period, if you haven't got information, what's your posterior? Okay? That posterior, the notation for that posterior is B mu Q. If the suspect, if the suspect does not reveal information in period 2, what's the probability that he's informed as you enter period 1? Okay? That's B mu Q. So here's the way that's calculated. On top, mu 1 minus Q is the probability that the informed type does not reveal information. He reveals information with probability Q, so he doesn't reveal information with probability 1 minus Q, multiply that by mu. It's divided by the total probability of no information being revealed. With probability mu Q, the informed guy reveals information, so 1 minus mu Q is the probability that no information is revealed, either by the uninformed type or by the informed type who stays silent. So here's the main trick in this equilibrium construction. Why do we need this thing? We need this thing to define the informed type's randomization probability in period 2. So in period 2, the informed guy reveals information with probability Q2 mu in order to make sure that mu star 1 is hit in period 1. Okay? So the informed type in period 2 has a target he has to hit, which I already defined. It's the target that makes the principal indifferent between torturing and not torturing in period 1. So the period 2 randomization is used to hit the period 1 principal indifference condition. Okay? That's Q2 mu. So given mu, okay, we can just put in a Q2 mu in here, so it equals mu star 1. Okay, you can kind of crank it out. So what's going on here is the randomization in period K is used to hit the indifference condition for the principal in period K minus 1. Okay? And mu star K, by analogy, mu star K is typically defined as an indifference condition for the principal to make him indifferent between torturing and not torturing. Okay, those are the two things going on in these two slides. And we just carry on. I've told you about period 1. I've told you about period 2. Here's period K. There are 3 equations that are used to define this equilibrium. And the 3 variables that are defined here are Vk mu, Qk mu, and mu star k. Let me start off with the third one. That says the period K randomization, which I've called Qk mu, is used to hit mu star k minus 1. So the period K randomization is used to hit the indifference condition in k minus 1. Second, mu star k makes the principle indifferent between torturing and not torturing, just like mu star 1 did. Finally, what's Vk itself? That's a little bit like V1. V1 had this min x delta mu minus C1 minus mu. Let's just take a look at this. Here are the differences. First of all, in period k, you've got k periods to go. You're not just going to get delta if he starts talking. You're going to get k delta. So a k is in there because you're earlier on in the game. So you can get more information out. Second, there's a qk term that appears here. In the last period, when I defined V1, I said suppose the informed type reveals information with probability 1. But actually, in earlier periods, the informed type randomizes according to equation 3. So there's only positive probability he's going to talk. So that number, let me just finish, is given by qk mu. So it's probably mu qk mu who reveals information, and then you get k delta or x, whichever is bigger out of him. With probably 1 minus mu qk, he doesn't talk, and then you torture. You torture both the informed type who has stayed silent and the uninformed type who can't say anything anyway. Yeah.
So Sandeep, but here the only time in every period you get information with positive probability because the guy
Yeah.
is informed randomly.
Yeah.
Why can't I commit to torturing to the end the moment information is revealed? I know it's the informed guy, and then I just commit to torture
Yeah.
all the way to the end. Why would I keep?
Implicitly, that's what's going on in this definition. You don't commit, but actually the unique equilibrium is that you carry on torturing till you get all the information. Okay, I'll get to that in a minute. Okay, but we can't vary the commitment assumption. That's going to come out of an equilibrium calculation. Okay, so define these things. So here's the equilibrium. In each period, as long as torture continues, the principal demands delta information. What does torture even start? That's the second, number 2. The principal begins torturing if and only if your prior, you can fold out back this mu star k to period t, the first period. You get a mu star t. If your prior is bigger than mu star t, you begin torturing. If it's less than mu star t, you don't even start. Okay? What if the suspect is kept silent up till now? Well, then you kind of randomize between stopping torture and continuing to the next period. Okay, so the principal's randomizing at the end of every period. And the probability of continuing depends on whether you're in a ticking time bomb phase or not. If you're outside the ticking time bomb phase, it turns out that you randomize and you continue with probability x minus delta divided by x. If you're inside the ticking time bomb phase, you torture with probability 1. You continue with probability 1. Okay? This will become clearer in a couple of slides. So that's the principal strategy, whether to start at all and whether to continue or not as a function of silence. What about the suspect? As the torture, in period case, as the torture continues and the suspect is so far kept silent, the informed suspect randomizes between revealing delta and keeping silent, and he randomizes according to QK. Okay? That's the QK thing I just defined. QK mu K, and mu K is going to be determined in equilibrium in a few seconds. As soon as the suspect reveals a bit of information, then he's tortured, he's threatened, I should say, with torture with property 1 thereafter, till he reveals all the information he has up till where time runs out. Okay? But this is not assuming any new commitment technology. This is just saying this is an equilibrium. Okay? So that's the equilibrium. So if the guy doesn't talk, the principal randomizes. And the suspect himself randomizes himself according to this QK thing from the previous slides. So what I want to do is show you this is an equilibrium and show you it's the best equilibrium. All right, so all the randomizations and so on have been defined so that conditional on silence. Remember how the QKs were defined? Okay, number 3. The QKs were designed to hit mu star k minus 1. So all the randomizations have been defined to hit mu star k after the first period. So what I'm going to argue now is actually the principal's payoffs, given the strategy profile, are always 0 in every period, apart from the first period. So his expected utility is just given by the first period's utility. So I'm kind of trying to work out the payoffs. So look at period 1. Period 1 was, mu star 1 was chosen to make the guy indifferent between torturing and not torturing. If he doesn't torture, he gets 0. And if he tortures, mu star 1 is chosen to give him 0. Okay? So let's say up to period k minus 1, that's also true. So the equality says basically v1 mu star 1 is 0. Assume vk minus 1 mu star k minus 1 is 0. It says that here. And now I want to prove inductively that basically it's also true for period k. Let's say you arrive in period k. You haven't revealed anything up till now. What's the continuation payoff for the principal? If the guy talks, which he does with property qk mu star k in period k, you get this information. If he doesn't talk, you torture. But by the way, you then enter period k minus 1. You torture him this period, then you get to period k minus 1, in which case your posterior now is mu star k minus 1. He stayed silent the previous period. And you get vk minus 1 mu star k minus 1 as well if you continue to the next period. Okay? However, by induction, this is 0. So you're left with a rest. And the rest is actually vk mu star k. And mu star k was chosen to make this equal to 0 as well. So basically every period, the principal, even taking his future payoffs into account, is indifferent between continuing torturing and not torturing. His expected payoff is 0. Okay? So all his payoffs are 0 for all k, apart from the first period, vt mu 0. So his entire value of the game, v is the value of the game to the principal, the entire value comes from the first period. Is that positive or negative? It's positive if mu 0 is bigger than mu star t. Mu star t again made the guy indifferent. And it's negative if it's the other way around. And if it's negative, there's no point even starting torture. So if mu 0 is less than mu star t, the value of the game is negative if he starts torture, so he doesn't torture. If mu 0 is bigger than mu star t, he does start torturing. And then the strategy is what I described. And the value is what I described, which is 0 the whole time. There are loads of zeros around, okay, in this, and that's necessary to make everybody indifferent so you can have a mixed strategy equilibrium. All right, so these are the values, and this is an equilibrium. Once you get the idea that there's, everybody's indifferent the whole time, this is a mixed strategy equilibrium. It's easy to see for the principal. Right? The principal's continuation payoff is always 0 in every period apart from the first. Hence, he's indifferent between torturing and not torturing. Hence, he's willing to randomize. Because I said sometimes he had to actually randomize. The suspect, that depends, his indifference conditions, because he's meant to randomize according to QK. So we've got to make sure he's indifferent too. Well, there are two different cases. If he's outside the ticking time bomb phase, then the principal himself randomizes between continuing and stopping. If he reveals information outside the ticking time bomb phase, he's then tortured thereafter, or threatened with torture, till he reveals all his information. So you get minus X out of him if he starts talking outside the ticking time bomb phase. What if he stays silent? If he stays silent, then in the first period he gets minus delta. The next period, if we reach it, the suspect's indifferent between revealing information and not revealing information. So we can look at the payoff he gets if he reveals information, and that's going to be minus X again. But he only gets to next period with positive probability, because outside the ticking time bomb phase, the principal randomizes according to this. And if you just do the algebra, a bunch of things cancel out, and this equals minus X. All right, so that's all that's used to do it. So the suspect's indifferent between revealing information and not revealing information outside the ticking time bomb phase, given the principal's randomization. Inside the ticking time bomb phase, if k is less than or equal to capital K bar, you may not have enough time to get X out of the suspect. You're going to get K delta out of the suspect if he talks. If he doesn't talk, you continue with probability 1. And the payoff, if you continue with probability 1 to torture, is minus K delta again. So again, he's indifferent between revealing information and not revealing information inside the ticking time bomb phase. So this is just showing that both guys are willing to randomize in the way I described, given the strategy profile I've constructed.
If you have too many minuses there, that doesn't go.
I don't think so.
That's correct. I do.
Yeah, you're right. That minus shouldn't be there. Yeah,
Yeah.
you're right. Yeah. All right. So this shows kind of the equilibrium sketch. But my main theorem is that, in fact, this is the best equilibrium for the principal. The maximum payoff across all equilibria with t periods is either 0 or Vt mu 0. If Vt mu 0 is negative, you just don't start. Okay? And if it's positive, you start, and that's your best payoff then again. So we found the best equilibrium. So intuition. There are two intuitions. First is what we call your spill your guts lemma. Once you start talking, you reveal you're informed. Okay? And then there's like a simple, that reveals you're informed, and then there's a simple backward induction argument that says then the guy threatens you with torture again and again and again and again. And so in each period, in the last period, he threatens you with torture, you reveal delta. In the second to last period, he threatens you with torture, you reveal delta, and you do a sort of backward induction to say, yeah, if you start talking, then you spill everything else that you have. Okay? So as soon as you start talking, you reveal everything that you have. That's got to be true in any equilibrium. So the informed guy, if he starts talking, reveals everything that he has. Okay? So we've got to give this guy the incentive to talk in the first place. And to do that, if we're going to get any information at all, and if we're going to do that, we have to threaten him with punishment if he doesn't talk. If the informed type talked all the time, then as soon as somebody stayed silent, you'd find out they're uninformed. And if you find out they're uninformed, you're going to stop torturing. So the only way to threaten punishment is for the informed guy to randomize and stay silent with positive probability. You've got to have silence with positive probability by the informed type. Moreover, since you're going to extract a lot of information if he starts talking, because in all equilibria you extract all the information he has, the punishment has to be big. The threat of torture has to be credible for a long time to encourage information revelation if you start talking. Right, okay, I already said that here, okay? So you've got to threaten to give the informed guy the incentive to talk. You've got to threaten the guy who stays silent with big punishment, to continue with punishment if he doesn't talk. That's why the randomization occurs. All right, so randomization has to occur in any equilibrium. What I want to argue is the best rate of information revelation is the rate that came out of my definitions, the QK, mu K definition. What happens if he talks faster? What if in period T, QT is bigger than QT mu 0? So we look at an equilibrium, a potential equilibrium where he talks more quickly. Yep. Well, then you're in trouble. Because in the next period, the principal's update is going to be mu t minus 1. It's going to be less than mu star t minus 1. You revealed information so quickly as the informed type that you're highly likely to be uninformed. For example, let's look at 1. Qt equals 1, the informed type reveals with probability 1 in the first period. Then in period 2, you know that you're facing an uninformed type. Okay? But in fact, for any Qt bigger than Qt mu 0, this inequality follows. But that then means the principal just stops in period t minus 1. He pretty much knows he's facing an uninformed type, he's going to stop. And if he's going to stop, then the informed type should deviate. He shouldn't reveal information in period 1, incur a little cost of torture, and then the next period he gets away with it. So we can't have faster information revelation than the Qt variables I defined. Slower information revelation than the Qt variables I defined is bad for the principal. The principal wants information revelation as rapidly as possible. Okay? And so doing it even slower has got to be bad for the principal. So QK defines the best rate of information revelation for the principal. This is the best equilibrium for the principal. All right, so that's it. We found the equilibrium. The entire value of the equilibrium is given by Vt mu 0, and then we can just do comparative statics with it.
Can you explain again why the suspect doesn't have a potential deviation lowering Qt?
The suspect is indifferent. The suspect is indifferent all the time between revealing information and not revealing information, given the principal's continuation policy. Okay? So he's indifferent the whole time, so you know he's willing to entertain any randomization. Okay? Now we can just do comparative statics with the variables in the model to look at Vt mu 0, see what happens. Let's say, and I'm going to do, here's what I'm going to do in this slide. Maybe this is the only slide I'll have time to do, okay? Suppose you only had one period to torture. Then your expected utility from the one period, so capital T equals 1, would be mu 0 delta minus C1 minus mu 0. Okay? That's it. Now let's say you can torture twice. So let's make it more frequent. But that's the only thing I want to change. I want to make everything else equal. So I'm going to rescale the punishment to delta divided by 2 and the cost to C over 2. So over 2 periods, the cost you incur is the same. The amount of pain you can inflict is the same. It's still delta. Well, then what's your expected utility as the principal? It all comes from the period 2 payoff. Vt is V2. There it is. It's mu 0, Q star 2 mu 0 delta minus C 1 minus mu 0 Q star 2 0 Q star 2 mu 0. Compare the two. This is lower. Why? Because the guy's randomizing. The guy has to randomize to get you to continue into the second period. So this number is lower than this. Moreover, you're torturing more frequently. Here you're only torturing the uninformed. Here you're torturing the uninformed and also with positive probability, an informed guy who stays silent. So your cost of torture is higher here than here. So your benefit's gone down, your cost has gone up. This is definitely lower than this. I've done 2 periods. You can make it more and more frequent. This is going to get worse and worse, and actually it becomes negative. All right, it becomes negative, and actually the value of as you torture more frequently, it becomes negative. Okay, so let me just conclude. There are lots of other things you can do, which all go in this direction, and I'm going to skip the rest. But here's the eventual conclusion. Torture without commitment has very weak power to extract information and becomes useless the more time and the less commitment you have. The frequency comparative static I just did was reducing commitment. You had 1 period of commitment. Now I made the period very, very small. I reduced your commitment and it just went to 0. You can also show if you increase t, it goes to 0. Okay, and so on and so forth. So that's basically the result. Let me stop right here.
Okay, thank you, Sandeep.
Okay, Barry?
Well, I guess before that last sentence, I was of one mind about this. Now I'm sort of a mind and a half.
Uh-huh.
It seems to me that, I mean, in a sense, you're out doing poster. I mean, he says
Yes.
you know the person has information, do it. You say if they might have information, do it. And so
No?
what's
Well,
really going on here? I mean, it seems, no, I'm not going to make sort of a technical criticism, really. I'm really asking what's happening here. I mean, there's certain things that we don't do because of who we are. I mean, this is related to my talking about taboos.
okay.
And so you're bringing this under the umbrella of economics. You know, you've got a cost and the benefits.
Yes.
And it doesn't make internal sense to me, really. I mean, we've known for a long time that mixed strategy equilibria don't have a coherent explanation as a strategy of what you do or don't do.
You may know that, but yeah.
Okay, so you don't agree, all right.
Yeah.
It just seems to me that to do this, I mean, suppose, you know, I don't want to be too critical, but I have to convey my reaction to this. I mean, let's have a model of whether a father decides to seduce his daughter or rape her. Okay, so let's draw it all out.
Yeah.
And come to the conclusion that he shouldn't do either. Okay, there's something odd about doing it. I mean, there's something odd about the whole activity. We shouldn't certain questions we shouldn't put into expected utility maximizing frameworks because
Right.
they're things we simply don't do.
Okay.
And I'm wondering if that seems to apply here.
Well, I just don't accept that. So Posner's argument is a utilitarian argument. Okay, so I'm going to just take it seriously. And this is actually from a discussion of a book that Alan Dershowitz wrote about whether the US should use torture. Okay, and all the calculations in the Dershowitz book are utilitarian. All right, so these arguments are being made already, and hence we have to address them.
Well,
Let me finish. I haven't answered your question yet. Step 2, the Posner argument you started off by saying was this says you've got an informed suspect in captivity, and therefore you should torture him. All right, where I'm doing an expected utility calculation, but actually his comment applies exactly to my spill your guts lemma. All right, so that exactly is the scenario that Posner had in mind, where if you've got an informed suspect, you know the guy has information about the thing that's going to explode, then you should torture him. And that's exactly what this lemma is. So actually his argument feeds directly into what I'm studying. And so there's actually a very tight connection between both the Dershowitz arguments and the modeling enterprise, and the Posner point and the equilibrium.
No, I can see you're definitely
Ye-
speaking to it.
Yes.
I see that. It seems to me that in doing things this way, you're granting their major premise, which is that it is a matter of weighing things. It's not a matter of who we are, what we do, and what we don't do. It's
Uh-huh.
a matter of weighing outcomes, one against another.
Even their variables, even if you accept your premise is essentially, I would say, capturable in this framework, which is what is the cost of torture? You're saying it's really, really huge, it's morally abhorrent, we shouldn't do it. So I don't think it's inconsistent with what I'm
Well,
saying.
if you go back to your inequality
Yeah.
that you had.
There are a bunch of hands,
for
yeah,
full commitment,
yeah, sorry?
if you go back to your inequality. the full
Exactly.
commitment Receives very high.
Exactly, yeah, exactly, right. So this may be positive, but my claim is VT mu 0. The more power the torturer has, VT mu 0 is negative, even if this thing is positive. Yeah.
So it was Dan that.
Yeah, Dan would have the
question,
time.
and then,
Couple of
Yeah.
questions. One is, a lot of this seems to hinge on this exogenous delta. One might argue that actually.
The exogenous,
The delta,
yeah,
that's a choice variable in
Yep.
some sense.
mm-hmm.
And I assume the
Yes.
incentive is to make it quite large?
No.
No.
That's one of the comparative statics I didn't do, okay? Is you can change, we can change delta. For example, we could use waterboarding.
Yes, I would say you get a lot of waterboarding episodes in.
So
I'm
that
just
would make
curious
delta higher.
Yeah.
Okay, I'm basically looking at things that can be used semi-legally.
Mhm.
Let's suppose we fold in waterboarding into that. First of all, that's more painful every period, let's say. So you're going to get more information out of the guy. However, it's also more morally abhorrent to society. The cost C also goes up. Okay, both at the same time. So here's the result for that case. Now I can present more of the papers I'm reading. Okay.
maybe, yeah. we can-
Basically, this waterboarding can lead to less information revelation and less utility for the
That
principal.
gets to my second question.
Okay.
So you seem to think that the biggest problem is the commitment problem. And we actually
Yes.
solve that pretty well. We find people who like to do this stuff.
Mm-hmm.
You put them in this little hut on Guantanamo that no one knows about.
Yes.
And sort of,
Mhm.
they work outside of anybody's scrutiny in some
Yes,
sense.
yes.
So we actually do solve that commitment problem by picking people.
I don't agree with you, so that's wrong. Yeah.
You don't agree with that?
No. So if we find people who like torture, that makes, then they carry on torturing. They can't commit to stop torturing, okay? Which is one of the two commitment problems that I have in this paper. You'd actually like to commit to stop sometimes, okay? And if you find people who like to torture, they're going to just carry on torturing all the time, and that makes this problem worse.
But you mean you can solve that by, for instance, giving them large benefits from, say, providing information that turns out to be verifiably accurate?
That would make them continue even longer. So I'm saying, actually, in this model, you want to be able to stop torturing. You want to carry on torturing innocent people, and you want to stop torturing informed people. Okay?
Right.
And then if you find somebody who likes torture, and you pay him for getting
You
information.
can't design a contract for such a person where if they provide you with the information.
You could,
fine with
but
that.
actually it'd be even better not to have somebody who likes torture, then you wouldn't even have to pay them to stop.
So we have, Brian, we have to stop in a little bit because
Yeah.
we'll take two more questions.
Okay.
and so-
Okay, this is an external question, so
Okay.
I sort of apologize for asking.
Okay.
Because I appreciate the model and the way you solved it. and
Yes.
everything.
Okay?
But the model makes some predictions, and
Yes.
we've assumed a lot about these people, they can do backward induction,
Yes.
everything. The model makes empirical predictions. Do you have any
Right.
comparison of the model with actual data?
So let me say, first of all, I'm not, the benchmark in this model is not a positive benchmark. It's a normative benchmark, okay? Because what I've done is looked at the best equilibrium for the principle,
I understand, yeah.
and I've said the best equilibrium is really bad. So actually, it's not a positive paper, in my opinion. It's a prescriptive paper, which says the value of torture, even in the best scenario, if you can't commit, is bad, is low.
But that's based on the assumption that the actors are going to work.
It is true that I've
way.
assumed rationality in achieving, in identifying this normative benchmark. If, you know, the principal's sadistic or something, I don't know exactly what you mean by, I don't know how to model irrationality, but there are many ways one could do it. But what, you know, they would give, some would give a lower utility. Okay, so this is saying it's irrational. So if somebody was irrational, they might get even lower utility than that's how I identified them as much.
Tony?
Another question that might be kind of external, perhaps a little unfair, is how much of this is dependent on the fact that you have two types, an informed or an uninformed type? If you have three types, say, a person who knows a little but not much, or even multiple types, does this dynamic work?
There's two issues, okay, with that scenario. Then you're going to get people being silent and then starting talking in period 2, in period 3, in period 4. And you're going to get some sort of screening over time. Okay, the highly informed guy starts talking with positive probability in the first period. Then the guy who's got medium information can't even start talking then because he doesn't know anything. And he starts talking later on, and so on. So you're going to get a more complicated equilibrium, step 1. Then there's another possibility that arises with more types, and that is, how do I want to call it, non-monotonic pooling. The middle type starts revealing information. Let's say there's high, middle, low. The middle guy starts talking. He only has a medium amount of information. You torture him for a medium amount of time. And the high type pulls with the low type. Doesn't talk at all. Okay? And gets away with it. Because he's pulled with the low type who doesn't have anything. And eventually you stop torturing. So what I'm trying to say is, with multiple types, there's one monotonic screening equilibrium that's like this. Then there's a non-monotonic equilibrium which endogenously creates commitment. The medium type starts talking first. You only torture for a medium amount of time, then you stop. So that second possibility arises, and you have to optimize around on that dimension. So that's just a technical thing. You just have to extend it.
You have a question?
I did. So, I guess going back to the things you just don't do, whether or not torture has an intrinsic cost, if you have, of course, your robotic torturers and your perfectly secret hidden prisoners.
As I said, this is a normative criteria.
You still have, there's a game that takes place after this, which is to say, we got this piece of information.
Yeah.
There's a cost associated with trying to verify it or trying to act on it, and then a cost associated with not.
Yeah.
And
Oh,
then
you
you
can
have
have
the
that
question of true and false information and
Yes.
sifting through that, and that seems like that
Yes.
might be more troublesome than this end in terms of the rational utility.
I don't think so. So, you know, if you add in unverifiable information into this, suppose the information is unverifiable, the utility of the torture would be even worse. So we've got an upper bound on the torturer's welfare. If it's negative with verifiable information, it's going to be negative with unverifiable information.
Well, I'm wondering if you have sort of a mixed type information where you have some information that's easily verified
Yeah.
and some information that's
Right.
high value. But
This would
high
be an
cost.
extension. This would be kind of an extension where you add something in. I mean, it's not.
Okay, we have run over time, but I have one comment, just
Okay.
sort of a small comment
Yeah,
about,
please do.
about the ticking, assuming that the ticking
Yeah.
time bomb
Yeah.
is sort of a real scenario, is empirically sort of relevant, and there is a lot of evidence that it's not.
Yeah.
Because precisely of this unverifiability of information.
Uh-huh.
Because somebody will tell you, well, how do you know, first of all, it will be in K days or something like that? And
Yes.
second,
Yes.
they just spill their guts, but they give you sort of all sorts of irrelevant information. And
That's-
that's something that makes it sort of,
Yeah.
that's all.
Okay.
So thank you very much.
Thank you.
for-